So now that we've looked at inverses, you're going to have the assignment. You should have the paper now. And we're going to look at some of the examples. We've already done example one. Example one I did on the previous page. When we were talking about the inverses here, this one down here was example one. That was number one on your assignment. So now let's look at actually finding inverses. And what you're going to do with finding an inverse is you're actually going to solve to try to find what would happen if I switched the domain and range. Now let's look back at domain and range. What did we say domain was? Isn't domain all of our x values? And what is range? Range is all of our y values. So if I want to find the inverse function, that means I want the x's and y's to switch, correct? So this is what we're going to do. Let's come back over here. If I want the domain and range to switch, I'm going to do just that. I am going to flip the x and y. So instead of y equals 3x plus 2, I'm going to write this as x equals 3y plus 2. So what I've done is I have flipped the domain and range. But to find the true inverse function, you want the y to be by itself. That is your f of x. So we're going to manipulate this equation and solve for y. So the first thing I'm going to do is I'm going to subtract 2 over, and that gives me x minus 2 on this side and 3y on this side. And then my last step would be to divide everything by 3. So that gives me y. I have negative 2/3. I cannot reduce that. And then I've got 1/3 x. And this is my inverse. This function right here is the f negative 1 of this function up here, which is f. Now, could I write this the other way, and should you probably do that to help you? Sure. You can write it as y equals 1/3 x minus 2/3. You can write it that way. But those two functions are inverses. All we've done is switch the x and y, and then we solve for y. So let's look at number 8 on your assignment. On number 8, you have y equals negative 3/4 x plus 5. So we're going to do the same thing. We want to find, that function is your f. I want to find f negative 1, which is your inverse. So my first step is going to be the switching of the x and y. So I'm going to make this x and this y plus 5. Okay? So now we're going to solve the equation just like we did. We want to get the y all by itself. So let's move that 5 over first. So I've got x minus 5 equals negative 3/4 y. Okay? Now going back to your algebra skills, because you know you all have skills. You got skills. You love to say that. Going back to your algebra skills, how do we get rid of a fraction from an equation? There's two ways. If you just want to get rid of the denominator, you multiply the whole thing by the denominator. If you want to get rid of the whole fraction, you multiply the entire equation by the reciprocal. So I'm going to multiply this by negative 4/3. And I'm going to multiply this whole side times negative 4/3. I have to multiply everything by negative 4/3. Again, the reason I'm doing that is because look what's going to happen. Cross reduce, cross reduce. What am I left with now? Just a y. Okay? And then we're going to distribute this guy. What's negative 4/3 times x? Well, you guessed it, negative 4/3 x. What's a negative times a negative before we even do anything going to give us a positive? And what's 4 times 5? 20. And then what's my denominator? 3. So this is your inverse function. Now don't let the fractions scare you. You just have to know the math steps that you have to take, okay? So again, to review, you switch the x and y, and then you solve the equation for y. You get y by itself, and those are your inverses, okay? So let's take a look at number 3 on the calculator. If I wanted to verify that these are in fact inverses, let's graph the original function. So I've got y equals 3x plus 2. Okay, that's my original function. That's a linear function, by the way, remember, mx plus b. The inverse is this function. The inverse is 1/3 x minus, and I always put parentheses even though sometimes you don't have to, 2/3. So let's graph this and see what it looks like. If you notice with inverses, there's always an axis of symmetry. If I drew a line right here, it'd be right in between those two. So let's actually check our table and see if it follows true to what the format is. Okay. According to the rules for inverses, the first two are your original function, x and y. So when x is 1, what should y equal? 5. Okay, that's your first one. Well, that means for the inverse, when x is 5, y should be 1. And that's true. You can see. So when x is 1, y is 5. For the inverse, when x is 5, y is 1. Let's try another one. When x is 2, y should be 8. That means in the inverse, when x is 8, y should be 2. And there we go. So that's how we know we have the correct inverses. Okay, so that's how you can check it in the calculator. And again, you have f and f negative 1. Now you can write f negative 1 of x, make these f of x, but you'll see it written both ways. Sometimes you'll see it written f and f negative 1, and it means the same thing. Okay, so let's do a couple more from our assignment here. Let's drop down to number 12. So number 12, we have y equals x squared minus 4, okay? X squared minus 4. So I want to find the inverse function. So what am I going to switch? The domain and the range. So now I'm going to have x equals y squared minus 4. And then I just solve for y. So my first step is going to be to move that 4 over, plus 4. So x plus 4 equals y squared. And then what do we do here if we want y, but we have y squared? Okay, it comes under the same principle as what if I had x squared equals 25? What would I do to both sides? I would square root it, right? Same thing here. I'm going to take the square root of both sides. I can't really do anything with x plus 4, so that's just going to stay square root of x plus 4. Square root of y squared is y. So that is your inverse function. Now notice, when it's a quadratic and it's squared, its inverse is a square root. Okay? Just like if we talked about if the function was a cubic, the inverse would be a cube root. So let's do one more. Let's look at number 17. Number 17, we have y equals the square root of x plus 8. Okay? So I want to find the inverse function where the domain and range switch. So I am going to flip the x and y. So I now have x equals the square root of y plus 8. So I'm going to solve this equation for y. So the first thing I do is I subtract the 8, and that gives me x minus 8 on this side and square root of y on that side. So let's take a look here. I want you to look at number 12. In number 12, we had y squared, right? And so to get y, we square rooted it. Okay? Now I have square root of y, and I want to get y. So I'm going to reverse that. If I have the square root of y, how would I just get y? Well, I would square it. So now instead of square rooting both sides, you are going to square both sides. Because when you square both sides, square root of y times square root of y will give you what you're looking for, which is just y. And then we just leave it x minus 8 squared. And that is your inverse. So that's how you find the inverses from the different functions, okay? We will do one more. I'm going to do one more because I want to do a cubic. There's not a cubic on your assignment, but I am going to do an example here of a cubic. So we can do a cubic inverse, okay? So let's say I have y equals x cubed minus 7. Now that's a cubic function. And I want to find the inverse, okay? Just like up here, this was f, and this is f negative 1. This is f, and I want to find f negative 1. I'm going to switch the domain and range. So I'm going to flip-flop those. So x equals y cubed minus 7. Again, you're flip-flopping your domain and range. So my next step, I'm going to solve it just like I did with the others. X plus 7 equals y cubed. And as we spent a lot of time on the last few weeks, when you have a cube, how do you get it to a single? By taking the cube root. So I'm going to take the cube root of both sides. I can't do much with this, so that's going to be the cube root of x plus 7. And this is the cube root of y cubed, which is just y. So there is your inverse function. So that is how you find an inverse given a function.